NH4OH will dissociate and form NH4 plus and OH minus. At the same time, NH4 plus and OH minus will combine and form NH4OH. In an acid, how many number of hydrogen atoms can be replaced are called as the basicity of an acid. Acids are the substances which can donate H plus ions. That's same as that of Arrhenius theory. And bases are the substances which can accept H plus ions or accept protons. They are called as bases. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today we are back with session 5 of the chapter Equilibrium. So in last session we discussed about the different factors affecting equilibria, right? And we studied a very important principle which is called as the Le-Chatelier's principle. Yes, and how depending on various factors equilibria will affect. Yes, the change in concentration, change in temperature, change in pressure, effect of catalyst, addition of inert gas, all of this we discussed in the last session. So in today's session we are going to start with a new topic, that is ionic equilibria, right? So before that we need to be knowing what is electrolytes, the different types of electrolytes, right? And then we are going to study Arrhenius theory of acids and bases. So you are already familiar with what are acids and what are bases. So there are certain theories which were put forward by different scientists on how you can classify an acid and a base. So the first theory was Arrhenius theory of acids and bases. Next one is Bronsted-Lowry theory of acids and bases, right? And then what are conjugate acid-base pairs? We are going to study conjugated bases for acids and amphoteric substances also we are going to study. Okay, so in detail we are going to study about ionic equilibrium. So to study about that we need to be first knowing about what are electrolytes and different types of electrolytes and things regarding that. Okay, coming on to ionic equilibria. As you can see from the name itself, ionic equilibrium. It will be something related to ions, right? Okay. So I hope you are familiar with this word electrolytes. So these are substances which conduct electricity both in molten state and in the solution state. Okay, molten state or in solution state they will conduct electricity. So for example we can take sodium chloride. Sodium chloride, but in its solid state, right? In solid state it will not conduct electricity. Either in its molten state or in solution state only it will conduct electricity. So how exactly it is able to conduct electricity? Sodium chloride will dissociate into what? Na plus and Cl minus ions. So because of the presence of these ions, it is able to conduct electricity. Okay, so such substances are called as electrolytes, which in their molten state or solution state can conduct electricity. Other examples are H2SO4, CH3COH, etc. Okay, now what are non-electrolytes then? Non-electrolytes will be those in their molten state or solution state which cannot conduct electricity, right? So these are substances which don't conduct electricity both in the solid as in solution state. Okay, electrolytes also, they don't conduct electricity in their solid state, only in molten state. But coming on to non-electrolytes, in any state, it won't be conducting electricity, right? So example is benzene, C2H5OH, that is ethanol. All these are examples of non-electrolytes. Now moving on, in electrolytes itself, there are two types, that is strong electrolytes and weak electrolytes. So what are strong electrolytes? These are electrolytes which undergo complete ionization in solution, which undergo complete ionization. Ionization means what? That particular compound will dissociate into its constituent ions. So the same example, sodium chloride we can take. It will completely dissociate into Na plus and Cl minus ions. So this is called as a strong electrolyte which will completely dissociate into its constituent ions. Then you have weak electrolytes. So these are electrolytes which undergo partial ionization. They do not undergo complete ionization into its constituent ions, partial ionization. For example, we can take CH3COH or else NH4OH. Okay, ammonium hydroxide you can take. So NH4OH will dissociate into NH4 plus and OH minus. Okay, and at the same time you can see that a reversible sign is shown here. The same way, at the same time the ions will combine and form the compound. That is, from NH4 plus and OH minus, NH4OH will be also formed back, and there will be an equilibrium which is attained between these two. That means that NH4OH will dissociate and form NH4 plus and OH minus. At the same time, NH4 plus and OH minus will combine and form NH4OH. So when these two processes are happening at the same time and at the same rate, what we can say? Yes, an equilibrium has attained, right? And what type of equilibrium it is exactly? It is ionic equilibrium. I hope it is clear. Right. So in a solution of weak electrolyte, an equilibrium is established between ions and the undissociated molecules, and that is called as ionic equilibrium. So let's take the same example. This is the undissociated molecule, right? Ammonium hydroxide is the undissociated molecule which dissociates into NH4 plus and OH minus, right? So there exists an equilibrium between ammonium hydroxide, which is undissociated, and the dissociated ions, right? So this equilibrium is called as ionic equilibrium. So I hope electrolytes, non-electrolytes and strong and weak electrolytes are clear for you. Now moving on to the first theory of acids and bases, that is Arrhenius theory of acids and bases. Okay, so you have a small idea about what are acids, what is the taste of acids, how you can detect acids using pH paper, all of that might be familiar for you. So first let's move on to Arrhenius theory. What did Arrhenius theory say? That how can you identify a compound whether it is acid or base? So according to this theory, acids are substances which can donate proton or hydrogen ion. So acids are substances which can donate protons, H plus ions. So for example, you have HCl, H2SO4, HNO3. In all these cases, you can see hydrogen atom here, right? And these can be, that is your proton. Protons means what? H plus ions. It can donate H plus ions. So such substances are called as acids. And bases are substances which can donate hydroxyl ion. That means they will contain OH minus. Okay, so how can you identify acids based on Arrhenius theory, or what are acids based on Arrhenius theory? Those substances which can, yes, release H plus ions or donate protons are called as acids, and which can donate OH minus ions or hydroxyl ions are called as bases. Clear? So Arrhenius acids can donate H plus ion and Arrhenius bases can donate OH minus ions. So I hope it is clear. So this is Arrhenius theory. Right. So moving on to the next one, that is basicity of an acid and acidity of a base. So as you can see, it is quite opposite to each other, right? So it's not generally mentioned as acidity of an acid or basicity of a base. It is acidity of a base and basicity of an acid. So how can you determine the basicity of an acid? Let's see. Basicity of an acid is equal to the number of replaceable hydrogen atom present in one molecule of an acid. So in an acid, how many number of hydrogen atoms can be replaced are called as the basicity of an acid. So for example, if we are taking H2SO4, how many replaceable hydrogen atoms are there? You can see it is H2, right? So 2. So the basicity will be 2, right? Now H2C2O4, again you can see it is 2 here, right? Now let's take HNO3. Only one hydrogen atom is there which can be replaced. So HNO3 is called as monobasic. Why it is called monobasic? Only one hydrogen atom is replaceable. Now H2SO4 and H2C2O4, they are called as dibasic acids. Why they are called dibasic? 2 hydrogen atoms can be replaced, right? Now H3PO4, if we are considering, how many atoms or how many hydrogen atoms are there which can be replaced? There are 3. So it becomes a tribasic acid. So based on this, you can say the basicity of an acid. That means how many number of replaceable hydrogen atoms are present, right? Now acidity of a base, let's discuss. Acidity of a base. It is equal to the number of replaceable hydroxyl groups present in one molecule of a base. Okay. How many replaceable OH minus groups are there in the substance is called as the acidity of a base. So for example, KOH we are taking, one hydroxyl group is present, right? Yes. So it is a monoacidic base, we can say. Now calcium hydroxide, CaOH twice. How many replaceable OH groups are there? Hydroxyl ions are there? There are 2, right? So it becomes a diacidic base. I hope it is clear. So this is how you can calculate the acidity of a base or basicity of an acid. Now moving on to the next theory, that is Bronsted-Lowry theory of acids and bases. So again, just to recap this, the first one was Arrhenius theory of acids and bases. So according to Arrhenius theory, acids are the ones which can donate H plus ions and bases are the ones which can donate OH minus ions, right? Now moving on to the next one, that is Bronsted-Lowry theory. According to this theory, acid is a substance which has a tendency to donate a proton And base is a substance which has a tendency to accept a proton. So in Bronsted-Lowry theory, we are not going to discuss in terms of hydroxyl ions. In terms of OH minus ions, we are not going to discuss. It's just that in terms of proton, we are talking about acids and bases. So acids are the substances which can donate H plus ions. That's same as that of Arrhenius theory. And bases are the substances which can accept H plus ions or accept protons. They are called as bases. And we are not talking in terms of hydroxyl ion. So I hope it is clear. So acids can donate H plus ions and bases will accept the H plus ions. So for example, let's take HCl plus H2 gives H3O plus and Cl minus. As you can see here, it was HCl here. HCl is an acid according to Bronsted-Lowry theory. Why? Because HCl is an acid, it is able to donate its electron and form Cl minus, right? HCl, hydrogen is being released and it forms Cl minus. Now at the same time, water, yes, it accepts that H plus ion and forms H3O plus. Okay, so this is how you can identify acid and a base. Now in this example, HCl donates the proton, so it is an acid. As it is donating the proton, it is an acid, and H2O accepts the proton, so that will become the base. Clear? Now moving on to conjugate acid base pair. Okay, conjugate acid base pair, which is a very important part. These are pairs of acids and bases which differ by a proton. So if you have an acid, you have a conjugate base for that acid, and if you have a base, you have a conjugate acid for that base. So how you can calculate the conjugate acid or base for a substance? Let's see. So consider we are having a base NH3. Okay, ammonia, which is a base. So how you can write the conjugate acid for this base? Conjugate acid for this base, it will differ by only a proton. That means what are bases? It can accept H plus ions, right? So what happens? It will accept one more proton and form NH4 plus. So this is the conjugate acid for ammonia. Ammonia is the base and NH4 plus is the conjugate acid. So it is as easy as it is. You just have to add one more proton to it. You will get the conjugate acid. So now you have water, which is the acid here. Now what about acid? It is ready to release its H plus ions, right? So what happens? H2O will release its one hydrogen atom and form OH minus ions. Okay, H plus ion will be released from there. So this is your acid and this will be the conjugate base for that acid. Okay, so if you have a base, how can you write the conjugate acid for it? By adding one proton. Okay, so you will get the conjugate acid, right? So now let's say if you have an acid, how you can form the conjugate base for it? It has to release that H plus ion, right? Conjugate base will be formed by removing one H plus ion. Okay, so let's take some examples now. First one is HCl. It is a Bronsted-Lowry acid. So it means that it is ready to donate its H plus ions. Okay, so this is the acid. How can you write the conjugate base for it? By removing one proton, right? So H plus will be removed, you will get Cl minus. That will be the conjugate base, right? It is the acid. All these are acids and these are the conjugate bases of it. Now the next one is H2O. Again, to get the conjugate base, remove one H plus ion. So what you will get? OH minus. Now from H3O plus, one H plus ion is removed, you will get H2O, right? Now H2SO4, one H plus is removed, you will get HSO4 minus. One H plus is removed, right? So it will become HSO4 minus, right? Next one NH3. Okay, from ammonia, it's a base actually. If you want to write the conjugate base of it, what you have to do? You have to remove one H plus ion, you will get NH2 minus. Right, that is a conjugate base. Now NH4, it will become NH3. Now H2S, if we have to remove one hydrogen or one H plus ion, it will become HS minus. Right, next one HNO3. This hydrogen or this H plus ion will be removed, you will get NO3 minus. Last one HCl4. This one will be removed, H plus ion will be removed, you will get ClO4 minus. So this is how you can write the conjugate base for an acid by just removing one H plus ion or one proton. Now, what are amphoteric substances? Amphoteric substances means which can show two behaviors. Okay, it's the same substance which can show two behaviors. So in case of acids and bases, these amphoteric substances are those substances which can act as both an acid as well as a base. So these are substances which can act both as acid as well as a base. For example, water, ammonia, all these are examples of substances which can act as an acid as well as a base. So let's take the example of water. In the first case, water we are taking or considering it as an acid, and in the next one we are considering it as a base. Okay, so if in this first one, water is an acidic one, it is an acid, how can you write the conjugate base of it? By removing one H plus ion. So you will get OH minus, which is the conjugate base of this acid, by removing one H plus ion. Now moving on to the next one, this is a base now. Water is a base now. How you can write the conjugate acid of it? By adding one H plus, right? By adding a proton. So to H2O, we are adding one more H plus, it will become H3O plus. So this is the acid and this is the conjugate base for it, and this is the base and this is the conjugate acid for it. So I hope it is clear. So in this case, as you can see, it can accept H plus ion as well as donate its H plus ion. So water can act as both an acid as well as base in different conditions. So hence what you can say, water can act as both an acid and a base. Okay. Now moving on to some problems. What will be the conjugate base for the following Bronsted acids? So some Bronsted acids are given. So Bronsted acids means what? It can donate its H plus ion. So we have to write the conjugate bases for those acids. So the first one is HF. So what will be the conjugate base for that acid? How we can obtain it? By removing or by donating one H plus ion or one proton. So it will be F minus, right? Next is H2SO4, from which again one proton will be lost. You will get HSO4 minus, right? HSO4 minus, and the last one is HCO3 minus. Again from this one proton will be lost. You will get the conjugate base for that. So that will be CO3 2 minus. So the next question, the species H2O, HCO3 minus, HSO4 minus and NH3 can act both as Bronsted acid and bases. For each case, give the corresponding conjugate acid and conjugate base. Okay. So the first one is water. So here we are going to write the conjugate acid and let's write the conjugate base here. Okay. So the first one is water. So the first one we are going to consider is water. So how can you write the conjugate acid for it? So if you have to write the conjugate acid for it, this will be considered as a base, right? So if it is a base, what is the tendency of the base? To accept one more H plus, right? So what happens? H3O plus will be obtained. That is one more proton will be added. So this will be the conjugate acid. Now if we have to write the conjugate base of it, how you can write the conjugate base of it? By the removal of one more H plus, right? So you will get OH minus. So I hope that is clear. Now the next one is HCO3 minus. HCO3 minus. Again to write the conjugate acid of it, we are considering this as a base. So base means yes, one more H plus will be accepted. So you will get H2CO3. H2CO3, right? Already one hydrogen is there. One more H plus will be accepted. Now moving on to the conjugate base, this H plus ion will be released. So you will get CO3 2 minus. Okay. Now next one is HSO4 minus. So to HSO4 minus, if you are considering this as a base, how will you write the conjugate acid? Yes, by adding one more H plus, right? So you will get H2SO4, which will be the conjugate acid. Now the conjugate base, by removing the H plus, you will get SO4 2 minus, right? SO4 2 minus, one more H plus is removed. Now the last one is NH3. So to NH3, to write the conjugate acid of it, we are going to consider it as a base. So base means one more H plus added. So you will get NH4 plus here. And if you remove one hydrogen or one H plus ion, you will get the conjugate base for it, which is NH2O minus. Okay, so I hope this is clear. This is how you can write the conjugate acid and base. So if you have to write the conjugate acid of a substance, you have to add one more H plus ion. And if you have to write the conjugate base, remove one H plus ion and write it. So it is as simple as that. So in the next session, we are going to study the next theory of acid and bases, which is Lewis theory of acids and bases. So I hope the concepts that we have covered in this session is clear for you. So that's all for today. Thank you.